Do I run queue? Okay, I can block queue. The time you want me to?
Ooh.
Do you want me to run the timer in the queue?
Okay. Let's start.
Yeah.
Good afternoon, folks. Welcome to the V6OPS session. This is Xipeng Xiao and Nick Bragorio. We will first quickly go through the chair's slides. First, the IETF nowhere. By participating in the IETF, you agree to follow IETF process and policies. If you are aware of any IETF contribution is covered by patents or patent application that are owned and controlled by you or your sponsor, you must disclose the fact and not participate in the discussion. As a participant in or attendee to any IETF activity, you acknowledge that written, audio, video, and photographic records of a meeting may be made public. Personal information that you provide to IETF will be handled in accordance to the IETF privacy statement. As a participant or attendee, you agree to work respectfully with participants. Please contact Ombudsman's team if you have questions or concerns. We always remind ourselves we work as individuals and try to be nice to each other. So housekeeping issue, please scan the QR code or sign the blue sheet, or if you sign in from MeEco, then you'll be done. Please also use your mobile to get into the queue before you walk to the mic. And before we present the agenda, we'd like to especially thank Ron as a co-chair and welcome him as a technical advisor. Ron mentored me and Nick, when we become the co-chair, and advise on important draft decisions. And I think that what we especially appreciate is that sometimes, we are guessing, what the IESG will think, because Ron was IESG member before, so I think that he can give us very good advice that we really appreciate. Now coming to the agenda today, we have a very tight agenda. We have 3 working group draft, 5 individuals, and 4 discussions. It's more than, if we add up, it's way more than 120 minutes. So we hope that all speakers will at least keep your time. If we look at the status from a draft perspective, we see quite a few individual drafts. We also see 2 more RFCs since the last meeting. And we also saw that the attendees go up. Now, I think that we probably must come to the conclusion that, the number of attendees is just a natural frustration. From the whole working group perspective, we made quite some progress since the last meeting. The big one is the group is rechartered, and again, this was led by Ron. We also have 2 draft published as RFCs, 3 other draft in working group last call, including 1 in RFC editor queue. So when it comes to the importance, so we have new milestones, and we encourage everybody to contribute to the new milestone, and also to Brian Carpenter's book that will be useful for the education. And the last one is regarding the providing input to to the Happy Eyeball working group regarding the logging. I will correct myself. I just had some discussion with Jordi, and we'll probably do the because Happy Eyeball V3 may go to working group last call pretty quickly. So we may provide the input to the Happy WG directly so that it may be processed faster. And our AD also advised us that we will coordinate with Happy WG so that our requirement is heard. So I think that that's the chair's part. Any questions? Well, if not, let's move on to our first presenter, Tim. You can now control the.
Okay, so I'm presenting today on behalf of my co-authors on a working group document about IPv6 customer edge routers. It's also a chartered item, so it's something we as a working group want to get done. Okay, so what changes have we made since the last time we talked? We added hop by hop processing, which is a newer RFC to it. Said, hey, you should do that. We adjusted the routing advertisement interval. This is a new requirement we added actually early in this process, and we just shortened it a little bit more based on feedback we got. So now the min interval is 2 minutes and the max interval is 3 minutes. I don't have super strong feelings about this one. I don't think any of the authors do. It's just a request, so we did it. RA guard, this is on the other side of that. RA guard, this is something that if a home gateway or CE router does it, and it can mess with snack. So this is one of those things where we mentioned don't turn it on by default. Your user in this case can be an operator or the end user. Either one, they have to know what they're doing and should turn it on. It shouldn't be on by default. So those are the easy ones we took this time. This is the biggest change. So the guys just talked about 9818 was the RFC that this working group did for prefix delegation on the LAN side of home gateways. So this is taking operators have been doing a fairly good job of giving out prefixes that are large enough for the home, but they don't make it past the first router. So we put out an RFC for doing that. What we did was we took all those requirements and we just dropped them straight into 7084 biz. So there's a whole new series of requirements. They are today verbatim what just came out, which we think makes the most sense. So that's good. Good news there is we managed to time this right. So any questions about any of that stuff? Good? All right. Yes.
3 minutes is too low. Okay. Like we should coordinate with Slack Renum. Right, because we're publishing that around the same time.
I had the values set to Slack Renum, and I can't remember why someone wanted to change it. It's in the issue.
Okay.
But
yeah.
I had it set to Slack Renum, but the Slack Renum was in its weird state where I wasn't sure if it was going to make it because it had been.
No, it's everyone is happy with it now.
Yeah. So I'm happy. So the answer might be yes. The next rev we can just sync up with Slack Renum. I think that's fine. I don't think we're on, like I said, I don't think any of the authors, or at least, I don't know, Jordy is nodding his head at me, and where's Ben?
Speaking of which, given that Slack Renum looks like it will sort of be published, we should say should or maybe even must use the values there. Because I'm tired of seeing routers that have like array lifetimes of 60 seconds. I mean, this is just like a hole in the head that we don't need.
Yeah, I still think, yes, I think we should sync them up. I have to go back and reread that. I think we took some of that already. So yeah, I'll make an action item for us to go through Slack Renum in its current state one more time, because you're right. Okay, so that's that. Prefix delegation. Okay. I was not wanting to talk about these, but here I am. Okay, so the M&O flags. So lately, and this is because there's a couple of open source implementations, namely OpenWRT and Purple OS, that now turn off their DHCP server if the M&O flags change. And it's not great. It's a really bad experience if you accidentally have two routers giving you different flags. It's basically awful. So the text I have here is the text I stole from the original 2462, which we removed for my 6-man people. We took those out when we updated neighbor discovery, but this text is actually really good because it basically says, hey, don't flap back and forth when you've discovered info. My suggestion, I do not want to do this for every node, but I think home gateways should definitely not be turning off their DHCP server. If they got an M flag that's true, they should just keep on the WAN DHCP server. There's no reason to turn it off or eject everything. It's fun to watch, but it's not great. It's not a great user experience at the moment. In particular, the one that's been giving me real pain lately is PD with this, because they're just ejecting all of their LAN addresses, and it's awful. So this is something I would like to add. Is there anyone against this? And again, I'm scoping this just to home gateways. I'm not trying to solve M&O flags everywhere. All right, great. Oh, thought I was going to make it.
I'm not against this at all. As an implementer, there's like basically nothing else you can do anyway. You basically say, well, like O is set to 1. You know, you could argue, well, if I have started something and it's exponential backoff and I haven't gotten anything yet, I might stop it.
Yeah, so the weird thing that happens with both of them is it actually has the information and then either one of them does a release and the other one just dies until it sees it again and then restarts.
I mean, doing release is absolutely wrong.
Yeah.
We should definitely, I would note that text doesn't technically prevent it, because like mustn't re-invoke it, but it could like release it.
Okay.
So basically what you have to say is that if you have you have to say that if you have a valid thing that you got, if you have a lease that's current, it is unaffected.
Yeah, okay, that's
Right.
fair. I think it should continue running DHCP v6. The change value has no effect, is what I've always taken that to mean. I've had to send this text, unfortunately, from 2462 multiple times to home gateways explaining, don't do this. This is a really bad idea. So I just want to put it someplace better than a document that we've overwritten a couple times. But yes, I'll take this text. People can look at it if they want to write more. I actually think it covers both cases. Obviously, we'll replace the word host with CE router, but I wanted to steal the actual text. Okay. So that's good. I think we're done. We don't have any open issues. We do have one. Wait, we have one issue. I screwed up the obsoletes, so I need to fix that, I think. And then Ben has a MR for me for all the horrible things I typed out that were typos that I need to fix. But other than that, we think we're done. We don't have any open issues. So we'd like this to go to working group last call. Look at all that time I gave you back.
So before we move on to the second presentation, Matt, our AD, want me to clarify this, that this time we don't have a volunteer to take notes. So we plan to use the automatically generated notes and then review it. Or, how should we do this? I think that we have Eric and Matt. Okay, thank you. Okay, we'll move on to the next. Jay.
Will you use clicker or are you gonna voice
Yes.
control? Okay. Hello. Let's talk about IPv6 mostly deployment considerations. Working group document. Mostly familiar faces, but let me do a quick recap. But IPv6 mostly we currently understand a network where different type of devices coexist. They could be V6 only, dual stack, or V4 only host on the same network segment, and hosts which are ready to be V6 only get into the state by using DHCP v4 option 108 to indicate to DHCP v4 servers that they don't need v4. In particularly, if you are on the IETF Wi-Fi network, you actually own V6 mostly network. And I deployed it in our corporate network. RIPE deployed it in their network. IETF did this. So we try to summarize what it is, how to do this, why to do this, and what kind of fun you should expect when you're doing this. Yeah. So document actually has been reasonably stable for a while. Actually, it's been almost a year since I presented it last time. And the reason was I was waiting for IETF NOC to deploy V6 mostly and to hear their experience. Thank you, Warren. And to see if their mileage varies and if anything they would like to add, things which I missed or didn't experience. So in the last 12 months, IETF SSID became V6 mostly. Warren and Joe kindly reviewed the document, provided their feedback. A few things were added. So diff for the last 12 months could be found in data tracker, obviously. What actually changed? It was a substantial number of editorial changes just to increase the readability, improve the readability. Most importantly, based on IETF NOC experience, we explicitly added considerations about selecting a NAT64 pool. I've never thought about that because in my network, for example, we use the same pool for NAT44 and NAT64, but IETF network is very special. They were using public v4 addresses. So when NAT64 was deployed, source v4 addresses for devices changed when they reached v4 only internet destinations, which would never happen it wouldn't happen in the network which was using NAT44. So we now have a section saying, hey, external systems might use IPv4 addresses of the client to some form of access control. It might be an ACL, it might be something else, but it would be desirable if your client does not change its source IPv4 address as remote site sees it. When you move it from dual stack or V4 only mode to V6 only mode, which practically means that it recommended to share the same pool between all forms of NAT, and NAT64 should be like sticky, so the same client gets the same address. Eric?
Eric Vink, how can you be sticky between the NAT44 and the NAT64 pool?
No. The document doesn't say that. NAT64 needs to be sticky.
Sure, but is it useful to be sticky in NAT64 and sticky in NAT44? And if you share the pool, the point is to keep the address, whether you are doing V6 and V4 internally, right?
No. The idea is that the same client should get the same V4 address when it's going outside, right?
Yeah.
For the given session. So if you never configured NAT before and now you configure it NAT64, right? Then you need to what? So
whatever. I guess
I'm
we'll
not saying you should get the same address always, but when when the client sits on the network, right, and it's going through NAT64, it's desirable that the client does not change V4 address it's mapped to. Yeah.
For sure. Now, whatever, I will read the draft. The NAT64 and the NAT44 sharing the same pool.
Yeah.
This could be interesting because my employer runs conference, maybe some Cisco Live, where we were doing this, and we were using different pool for NAT64 and NAT44. And as everyone was using NAT64, we exhausted the pool of NAT64, and the pool from NAT44 was still full.
Okay.
So sharing this is a nice idea as well. So kudos.
Well, thank you. Warren, you wanted to comment on sticky part? Yes, that's fine. I'm just slightly confused. Sorry. Well, maybe not slightly. Lorenzo?
So this means that you can't use different boxes for NAT44 and NAT64?
No, you can, like, okay, it's recommendations, right? If you know
Okay.
what you're doing and it's okay, fine. Because I think what's happened at IETF network, right? Yes, like source addresses drastically changed when the client moved from dual stack mode to V6 only mode. And it might be okay, it might be not desirable. So it's just a consideration you need to, Warren?
Yeah, I mean, basically the issue is we kept running into in Madrid was people would connect and get one mapped address, one NAT outside address, and then they would make another connection to the same website, and the site was trying to do authentication by being like, are you coming from the same address? So all we're saying is you should be sticky. NAT should fairly much always be sticky when possible, not between 4.4 and 6.4 or similar.
I
So
think Lawrence was
I
talking
think
about...
we're overthinking this. It's not that complicated.
Yeah. Yeah.
Yep. That's what we say, I think.
Yeah. Lawrence, I guess you're talking about previous sentence about share the pool. Yeah, it's okay not to share the pool, but at least you need to be ready to the fact that if it was ACL somewhere on the remote side, that ACL needs to be updated, right? If you don't want to deal with that, yeah, you might just want to share the pool. Or if you configure it on the same devices, it's just easier to share the pool. Anyway, so another issue discovered in Madrid, I think, and at the same time discovered by other people deploying this V6 mostly, is that laptops sometimes run firewalls, and those firewalls do not like atomic fragments, and some NAT64 implementations still following 6145 instead of 7915 and send atomic fragments. So those packets get dropped and it leads to general unhappiness of the users. I updated the text about UDP v4 packets with zero checksum. We've seen them in the wild, especially by some mobile gateways, which was breaking Wi-Fi calling. So it's not it's not something specific to V6 mostly, but it's just one of the issues which normally hidden when you have dual stack and which suddenly appears when you have V6 mostly. So two drafts for the price of one. Some text was added about using the well-known prefix in enterprise environment when you might want to talk to non-global V4 address space, but hopefully, fingers crossed, we have time at the end of the session to talk about another draft which discuss explicitly that. Next step. Elliot kindly provided very extensive review of the draft, and I'm going to publish the next revision which will address his comments. In particular, it looks like I need to emphasize that typical issues in the draft are not, in most of the cases, specific to V6. Mostly they exist in any V4-enabled network, but thanks to happy eyeballs, you might not notice them until it's too late. And just turning off V4 makes them much more visible. So if you know anyone or if you are deploying V6 mostly, please look in the draft and tell me what is missing there, if anything needs to be added or changed. Otherwise, I think it's ready for the last call. It's been quite stable.
Yes.
Questions? No?
Do you want to announce that there's a poll?
Good.
Yes,
No?
there's a poll.
Yeah, you want to? Rich.
So there's a poll on the.
Richard Patterson, Sky UK. The comment about, or the section that you've added with for UDP4 with zero checksum, I just had a quick read of it just now to check what you were suggesting. It was a bit unclear on if you were giving them a recommendation or just saying, no, just you have options to do.
No, like you can do much, right? Because I think one of the translations RFC, I don't remember which one, says practically they're very rare, basically do not exist, which is not true.
Yeah,
so basically what I'm saying is you might see them in the wild.
You definitely will, yeah.
Yeah, so it's just a warning, like, because we spend some time troubleshooting why Wi-Fi calling doesn't work.
So I guess the two options I think you mentioned were drop them or calculate a valid checksum.
Yeah.
I would suggest, and correct me if you have included and I missed it, the third option, which is translate and send it with a zero check sum in UDP 6.
No, 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 no. I would.
If you read, it's not. I'm not sure if it's an 8200 or which one it is in, but if you squint and you kind of interpret the RFC, it says if you're using V6 as a tunneling mechanism, you are allowed to do that. So this is translation, not strictly encapsulation, but if you squint and interpret it a certain way, it could be considered valid.
I did see equipment which is very much unhappy about IPv6 packet with zero checksum, a UDP packet. So I would be very careful about this.
If you own the V6 domain end to end and you can control that, then it's fine. There are implementations, both vendors and operators who are doing this today, us included.
Yeah, I've seen like equipment which just drop in them, so it might make the situation worse. Yeah.
Okay. Thank you. I think that our next presenter is Fan.
Yeah, hello.
Yes, we can hear you.
Hello, everyone. This is Fan Zhang from China Telecom, and I'm presenting the Young Data Model for IPv6 neighbor discovery on behalf of the IRO office.
You can tell me to go to next slide.
Okay, next. Yeah, this draft is about the Young model of the additional configuration and management of IPv6 neighbor discovery and related functions that are not included in IETF IP or IETF IPv6 unicast routing model. The IPv6 ND Young model, we defined it here, covers the
Fan, you are very loud, so I think that you can maybe, go down a little bit.
Okay, sorry. Is that okay?
Yeah, better now.
Yeah. This model covers the function like the IPv6 address resolution, redirect, proxy NOD, DAD, enhanced DAD, and the related statistics. Next. Here's are the changes from last time, and as you may know that this one was originally in RTGWG workgroup document, corresponding with another ARP Young model draft, and we've received comments that suggesting us to move that from RTGWG to 6-man, which might be better for the comments about the V6, and that's also the reason why we're here, and we want to get more operational and practical information about V6 ND and try to get better with the draft. Based on the comments from the last session and mailing list, we've changed the model name to IETF IPv6 ND and added notes about the enhanced DND and removed notes related to the send and send proxy as it has been removed from the IPv6 node requirements due to the limit use. And we also added a Prendex B to summarize the existing nodes related to IPv6 ND, which are separating different Young model from different RFCs. For now, the router configuration variable described in RFC 4861 and node configuration variables in 4862 are basically covered. Others function enablers for address auto configuration extension in 41 is been defined in IETF IP, and the enhanced DAD in RFC 7522 are defined in this one. Next. And that's it. Is there any comments? Okay, Aaron.
So Eric Wing, individual contributor, can you go back on the slide before? I don't know the complete set of fields everywhere, right? But my understanding is that the reachable time and the NS, the reachable time is per array, it's not per interface. Is it correct? Looking for the six-man chair in the room, they should know this from the top of their head, right?
Oh.
It's per array, right? No? Okay, fair enough. I bet.
Any other comments or questions? I think, okay. Thank
Okay,
you.
thanks.
Okay, quick reminder about this presentation. Instead of doing one slide set for every document, I did a single one because the overall idea is all the documents related to NAT64 and around to advance them. Some of them are informational, so the idea is to move them to standard, and some of them are already standard, so the idea is to move them to full standard, okay? So the first one, NAT64, I published just yesterday a new version because I needed to add some considerations, some IANA considerations that were not in my previous version. This IANA considerations is just to update the reference to RFC 6146 to the new document in case it's published, of course. The main changes between the actual RFC 6146 and the actual version, the actual this version, is updating the references. Of course, I contacted the authors, the original authors, to see if they want to approach this work or not. They actually didn't respond. A few years ago, I also contacted them. They told me, yes, go ahead. So the original authors are moved to a section for contributors to avoid any issues in case they are not contactable or they are not reachable in the out 48. I added an implementation status section following the recommendation from our AD. This was probably the most difficult part because, of course, all the vendors never publish all the RFCs that they comply, and it's not easy to find even sometimes in the documents that are online references to specific RFCs implementations, but I tried my best also from my experience doing actual deployments. So I tried my best. I specifically mentioned that maybe some of them are missing. So maybe there are other vendors that have already support for NAT64, but I was not able to find that in their public documents. So that will be for the NAT64. The next document is the translation, this RFC 7915. Again, here there is one errata that has been resolved. I think I forgot to mention in the previous one there were two erratas also resolved, updated the reference, and again with the author. So that's the only changes from the original document to this one. The next one, probably we need to hold it because Jen is going to do a presentation about this at the end. But if we don't hold it, the idea is basically this document didn't have erratas, no unused features, no patterns, and I also added, I think I forgot to put that in this one, yeah. I added here also the implementation references. I forgot to put in the slide. And that's it. So depending on the discussion that we have on the other one, this may be the one that we need to hold. We will see. Then we have RFC 7757. Again, no RATA, no unused features, no patents, and again, added implementation status section. Same for the 7755, exactly the same, which is CDC, and CTC dual translation mode, which is 7755, exactly the same. Okay, so this is the status of all the documents. I presented most of them, I think, already in Madrid very quickly. So the main change is basically added the implementation section, and the first two that, because they have erratas, they need to follow a different path. Now, what I believe, and this is checking with chairs and AD, is that the documents that have these, they need to be adopted as a working group and go to last call and then to the ASG. But the other ones, I am not sure, because they don't have erratas. We are just changing a status change. So from informational to standard, I believe those, we don't need to do anything as working group, or we need to adopt them and also do a last call. No, they go straight to the ISG, right? Yeah.
Mohamed Kader. Yes, so for those that we don't have any, I would say, change in the specification. So this can be just, I would say, administrative modifications you can do through the data tracker. So basically, I can do that when I receive, I would say, the comment from an individual, not from a working group. But given the importance of these documents, what I would really like to hear from the working group is that there's a consensus for us as a working group that we want this to be promoted. So I will leave it to the chairs to run this so that we can have a consensus on how we will be proceeding for this. And once I will receive this, there's a document in which I am the co-author, so I will be likely asking Eric to take it. But from the others, it will be just an administrative modification through the data tracker.
So I will say, in summary, we need a consensus call for those that go straight to the ISG. We can make a single consensus call for all, probably.
I will leave it to the chairs, separately or not separately, but it's something that you can figure out on this.
And then we need to do a working group adoption and last call for these ones.
Yes.
Okay.
Right. So maybe a quick summary of my discussion with Matt and also you. So for the one that changed, we will go through the normal standardization process. For the ones that didn't change at all, we are going to send email message on the list asking whether people have any objection to send it for Matt to take it directly to IESG. And if no objection, then Matt will take the action.
Yeah.
Basically for 7915, right now. So the difference between 79, so 7915 obsoleted 6145, and 6145 was SIIT, right? And that was a stateful, that was a stateless translation from 4 to 6, right? 7915 adds a stateful mode, but it doesn't say how it should work. So if we want to advance these to full standard, I think they need to be sort of interoperable implementations. But if you don't say how something works, it's hard to know what an interoperable implementation is. So I'm wondering, do we have other documents to describe how the stateful translation works? And if we don't, then how do we sort of advance that part of 7915 to standard? Because it doesn't say how you do it. Because I just looked through 7915 and it says like, oh, the translator can be stateful. And it doesn't say what it should do when it is. It says, oh, you must support an address mapping function. It doesn't say how it should look.
You mean the address mapping?
Yes.
But the address mapping is already in another document, the 7757, I think. Let me check. Yeah, this one. What is true is that because this document was probably later, there is not a cross-reference among them. We can add that probably. I am not sure about that. I am talking from top of my head.
Well, 7915 is a higher number than this, so I assumed it was published afterwards. So it should have been able to refer to it.
Maybe there is a reference already. I can take a look, and if it's not there, I can put somehow a reference to mention that.
No, but I don't think it's that simple, right? Because
No?
if this was already there when 7915 was published, then the reason if it didn't reference it, it means that it wasn't appropriate to reference, right? Okay, so I guess the question is, if if there's no document that explains how the stateful mode works, then we can't assert that they're interoperable implementations. And I don't know what that means. Maybe we have to take it out, or maybe we have to leave 7915 as proposed. I don't know.
Yeah. Okay.
Yes, but this 7915 is the SLIT. It's not the same as NAT64. NAT64 is well defined. It's sort of a stateful translation, and it's specifically from 6 to 4 with a flow in that direction. As I couldn't figure out how 7915 works in stateful mode. Maybe it's described in another document that I haven't found. It's possible, but I guess if nobody's standing up here to beat me with a club, so maybe nobody knows this. Okay. Then
well,
I would assert that so then I'm going to assert that to advance 7915 to full standard.
What is clear is that there is interoperability, right? So it's working. So maybe there is a lack of a description. We need to see that.
You can't assert that there's interoperability of a standard that doesn't specify how the protocol works. That's like not a claim you can make. And so, yeah. Anyway, I think what I would assert is if 7915 has this language that says there's stateful translation, if we don't have a stateful translation document that implements that, and if it's not described in any IETF document, I don't think we can advance this to full standard, because we're basically advancing to full standard something where we don't say how it works. And we can't say, oh yeah, we wrote this, whatever, 10 years ago, 7915, and we can't say, oh yeah, in the intervening 10 years, we've written no documents about how this would work, and we're going to promote it to full standard, even though nobody uses it, right? So.
Okay, I guess we need to take a deep look into the mailing list into this and see how we fix that, if we need to fix that, okay?
So 7915 definitely does not give enough information to satisfy Lorenzo's criticism. So we definitely would need to address this somehow. This is Ted Lemon, by the way.
So done. Okay. No.
Okay, we move on to you, Philip.
So hello, this is Philip Teasel. I'm talking about testing applications for IPv6 support, and this is new work brought to the working group. But before going into the draft and about what it's telling you, a little bit about the motivation, why to bring it here and how to bring it here. So everything started roughly 2.5 years ago with the advent of IPv6 only for application. And this was mostly motivated by the US governmental mandate M2107. So telling that they wanted to complete the transition to Internet Protocol version 6 for US federal networks. And this creates quite some pressure in parts of the industry to support IPv6 now actually properly in all their products. But what it also does, it redefines what supporting IPv6 means. And it does this by changing it from what most application developers so far anticipated, that the application should not break in the presence of IPv6 and may prefer IPv6 for its communication, like Java still prefers IPv4. Instead, what it does, it changes in a strict interpretation that the application must work in an IPv6 only environment without any functional regressions. And that's quite some change for most application developers and for the way how to approach testing applications for IPv6 readiness. So myself consulting this as a topic internally and being presented with this new requirement, the question that always arises was, oh, how do you have something on IPv6 application testing? Do you have some document telling me how to do that as a developer? Do we have some idea what's the documentation status is? And after a lot of research and a lot of discussions, the answer is there was nothing. So after 1.5 years of internal consulting about the topic, finding out how to do that, proving this on a relatively large portfolio, we decided that this needs to become best current practice. And we released the 00 version of that document while we were in Madrid. Circulated in a small round and just found my nice co-authors, Kyle, Ben, and Jen. And over the last time, we presented 01 to present it here now. So much about the history. Now, what's in it? So first, we have the objectives of what the draft should mean. So first, it should provide a concise definition of what supporting IPv6 means, because there is none. Even in the NIST documents, there's no concise documentation of what supporting IPv6 means. Second, we want to define base connectivity scenarios as a basis for how to do testing, give guidance how to carry out IPv6 testing, also including the lifecycle of the applications, and finally discuss common sources of IPv6 related failures and misbehaviors you should look out for and make sure that they don't happen. So while this sounds nice, we have to come to the difficult parts and the things we finally avoided. So the first thing is the definition of supporting IPv6. Supporting IPv6 is defining supporting IPv6 is not only difficult, it makes IPv6 testing, all the whole IPv6 debate, some kind of strange Unicode thing developers are supposed to heard from now on, and it's a special task, it's an unwanted task, and so we have to find a definition that makes more sense in the sense of traditional application testing and in the world of application development. And so instead of defining what IPv6 supporting IPv6 means, we just define a target state. And the target state is applications are expected to function regardless of whether they're used in more or less any environment. So being it IPv4 only, dual stack, IPv6 only, with and without connectivity to the IPv4 internet. So as we say, with or without Net64. The second bad thing is the thing of defining. So if you talk about IPv6 only networks, you actually have to define what IPv6 only means. And as Lorenzo is already laughing, that's something we as a community, we actively avoided so far. And that's the reason why we also actively avoided that. Instead, we define IPv4 only, dual stack, IPv6 with NAT64, and something I called true IPv6 only, which really means we have IPv6 without any connectivity to the IPv4 internet. And while this is a useful test target, I think that I'm 100% sure it's not a useful deployment target today. Just to make that sure. So based on that, now we define core testing objectives. And I think that the core testing objective is that IPv6 application testing should always be derived from functional integration testing. So we don't do some special unicorn tests for IPv6, but we take the test suite that's already there for functional testing and to adopt it in a way that we test whether it also works in the respective connectivity scenarios, which is much easier for most application developers because it's just a variant of the already existing testing instead of inventing something completely new. The clicker is a little bit lacky. Based on that, we have to look at what are the connectivity scenarios we want to test. And there, as we have translation in place, we have dual stack and IPv4 only and true IPv6 only in place. We have to get the nice metrics of what kind of connectivity scenarios you have from a client and server base. And while I'm not talking here about more special cases, you also have to add cases for with and without proxy. And you also have to think about cases where you are not client server, but something peer-to-peer applications. I'm not talking about this on the slides here, but there's already text in the document for it. And after going to that discussion, we look about how you can tame down the number of cases by ruling out the unlikely error cases. Yep. And after doing this, we talk about testing strategies. So best practices, how to approach IPv6 testing, especially given corporate environments or specialized environments when you can't just build test beds for everything you would like to test. And based on this testing strategies we described in the document, we would really love to see people reading the document and providing feedback on what we missed here. I didn't see. Do you have clarifying questions, or should we punt it to the end?
You can go to the end. Keep going.
Okay. And the second point. Next slide, please. I think the clicker doesn't work. Finally, we describe common sources of IPv6 related failures and misbehaviors. That's just a collection of things we found in practice that, yeah, are very problematic while testing. And also here, the call out to the community, please, if you find something that we've missed, please provide content, provide your experience with that. Next slide, please. And from there, I think I'm done with the overview. Let's start the discussion now. We'd love to get feedback, especially from different perspectives, because we mostly have this now from the software development company and the testbed operator perspective, and we would love to see more perspective on that. And second, we would like to know whether the community or the working group is interested to take the document and adopt it. With that, I'm happy to take questions.
So yeah, I definitely think Tim Winters, QA Cafe. I think this should be a working group document. I think it's, this is in a previous life, I spent a lot of time thinking about this. I think it's a really interesting way to split it up by the environment that they're deployed in. The only thing I would split hairs on is I would suggest your true V6 only, having both Slack and DHCP. Where this comes up with apps is when they need things like NTP certs. You can't do that with just Slack and causes chaos. So we ran into some problems back in the day when we were testing apps with that kind of thing. So I think you're going to want to acknowledge that, and probably, I hate having to say this, but you're probably going to have to split those into two different cases. And I'm sad that that's what you have to do, but that's where we're at. So that was my only other feedback. I'll take a read through this, and I probably have more stuff if I think about it more, but I did notice that.
Thank you.
Tommy Jensen, Cloudflare. I think the document is an excellent starting point. I don't have significant feedback on the test mechanisms themselves. I will point out that currently the document opens with a primary justification quoting a US government mandate without mentioning any others, and it feels a little over-focused. There are other countries that also have mandates, other market forces, and I think this document, in addition to being a testing document, is also a formal source of, so I'm an app developer and I'm struggling with this. Why is it that everyone cares that we could be referring to? So I'm hoping to diversify that opening.
That's definitely valuable feedback. So I can justify why I started that way, because it was basically my sponsor had only market force forcing it to go into IPv6 testing because of the US government mandate. But I know there are mandates from different states. So there's one in China, which is much stronger than the US mandate.
Yes.
There is one definitely in Germany, which is not executed upon, but that is at least long. There is one in the Czech Republic, and I think, yes, we should tame a little bit down from that focus on the US market and diversify that. That's very valid feedback. Thank you.
My previous and current employer, that's the one that's most prominent, but it also makes it harder because I always have to look up what's the German one again. So it would be great. Thank you.
Carlos from LACNIC. Thank you for this work. I think we should have done this a long time ago. For different reasons, particularly some family reasons, I've been acutely aware of this need. I have two comments. One is, I'm not sure, but it may make sense to add some connectivity scenarios related to severely constrained CGN deployments, which are common in some parts of the world. When you're coming from CGN deployments which don't have a lot of ports available, it's not IPv6 specifically, but it's related to IPv6 deployment and IPv4 runout. One of the things that I found trying to do something similar to this is that the tooling is not there. I mean, we are network engineers and we can rig things together using proxies and Dockers and whatever, but no normal software developer will do that. So I think this is great guidance to someone who may create tooling for this in a way that's deployable by software developers. And as an anecdote, I submitted a talk to a testing conference in Uruguay 2 months ago, and I got rejected. I was exactly about this topic. Thank you.
Thank you. About the testing, I agree that there's not much tooling on it. The document describes some scenarios how to do it with poor man's tooling as a developer you have available. And also during the hackathon, we released a small tool for at least web apps and for websites to do a little bit IPv6 only testing. You can look it up in the resources of the hackathon.
Okay, thank you, Philip. Let's move on to the next presentation.
Okay. Very quick history about this document. Is it working? Let's see.
Does it work?
Yeah. I started a long time ago a document trying to clarify different questions regarding point-to-point links. Almost in parallel, we have RIPE 690 that probably most of you already know. So what I am trying to do now is to put all them together and do a BCP. So the presentation is not explaining the details of the document because it's a long document, just a kind of summary, because it's, again, it's version 00 to try to get the working group contributing. So the document is trying to answer several questions like what size for the point-to-point links, how to number the point-to-point links, what pool to use for the point-to-point links, what prefix size should be assigned to customers, and should this assignment to be persistent or not, okay? Regarding the point-to-point links, there is a brief text describing the ping pong issue. Then we have considerations for the prefix size, numbering choices, a description of possibilities for the prefix pool, which basically is either a dedicated pool, which is the approach that we are using typically in IPv4, or using the first /64 from the customer assigned prefix. So if you assign a customer /48, the first prefix will be the point-to-point link. And this has been tested in a number of vendors, and it works, and it's something that is being done by many ISPs. Then I think it has low battery because it's taking. Then we have, I am not sure if I skip it too many slides now. Let's see.
Do you want me to go back?
I am trying to see if I skip it too many slides. That's the problem. Okay, that's the third one, 4.1, 5.1. Okay. So regarding the prefix assignment, as we say in the RIPE 690, there are ISPs that are using /48 in all the cases, and there are other ISPs that, to differentiate between residential and business customers, they use, for example, for business /48 and then /52 or 56, sometimes /60, which is very ugly, for residential customers. And what I am trying to say here, according to what we already decided to say in the RIPE 690, is that at all means avoid prefixes longer than /56. There is a small section for considerations for cellular operators, but because we already know that in this case we use /64 for each PDP context, but there are more and more cellular operators providing broadband. So in those cases, we need to assimilate that to the regular broadband providers via wireline, okay? Now 6, let's see if it goes to 6. I click it already. Okay, one more. Now, then we talk about prefix persistency. We argument that because there is no scarcity, there is not a real need for doing non-persistence. And then we explain, again, this is most of this, the text on this part is coming from RIPE 690. So we explain there that many ISPs believe that doing non-persistent is easier, but they forget then that they need to do logging, and it's an extra cost, etc., etc. So we explain all these rationales. Then we also explain about non-persistent is harmful because we know already flash renumbering, and definitively we recommend that persistent is the best practice. So this, I think, is my last slide. This is the summary of the recommendations. The prefix assignment to end sites must be GUA /48 using the IPv6 prefix delegation. The prefix assignment to end site must be persistent. The prefix for the one link point shall be a GUA /64. You can use /1 to 7 for the actual numbering. It is recommended that the prefix for the one point-to-point is the first /64 from the assigned end site prefix. There is a specific RFC, I don't remember right the number, it's the same used in cellular networks as well, to exclude that option from the PD. The assigned prefix must not ever be longer than /56. And basically, now it's working, that's it.
Lorenzo Colletti, can you go back one slide?
Yeah, if it works. Yeah, it's working now.
How can you use prefix exclude unless you know that the client supports it? And there's no requirement, right? To support
Yes,
prefix exclude? So then you
I don't
can't-
remember the RFC, but the idea is precisely in the document to make this a requirement. Okay, so
Nope.
so the CPEs should support prefix exclude.
But you can't, like, you can never, I say if you recommend it, right? But like there's like billions of CPs that don't support it. And literally, so, well, hundreds of millions, and you can't fix them. So I don't think we can make a recommendation that, don't think we can make a recommendation to use this, because on any current device, it won't work. And so like people are going to be very confused when we recommend it and they try it, and like they basically, it's not just that it won't work, it's like it will break pretty spectacularly, because you'll assign that prefix to the point-to-point link, and then the CP will also assign it to the LAN, and there's going to be a lot of fun for everyone. Right.
Yeah. Good point.
So
Yeah.
Because like, yeah, you'll put that more specific there, and the 127 will actually work and carry the traffic. But yeah, I mean, I don't think we can recommend this.
Now that I see Tim behind you, maybe we need to include this in the 7.4.
So you don't believe me, you'll believe him. Good. That's good. Yeah. The other thing was like the persistent. You know, I thought there was a perception that regulatory requirements, certain countries required that their prefixes be rotated. So
You said German?
I didn't say anything. I
Okay,
said there
because
was a perception.
there
that
was
might have
there
been.
was a rumor that the German government was mandating that, but it has been confirmed that it's not true. Okay.
I mean, so a couple things about the persistent, right? There's a privacy thing going on there that I don't know if we want to be wading into in this document. Like, I understand the benefits of this, and I think you can talk about that, but I would not put the word must in front of it. There are lots of ISPs who rotate that intentionally all the time for very good reasons. And I would not be a fan of must in this case. I think we can tell people, you know, as an operator BCP doc, like, these are the reasons you do this. These are the reasons you wouldn't do it, and go make your choices. For prefix exclude, if you want to do this, yeah, no, this is not something that's standard on anything that's not fixed wireless. Anything that's fixed, like has a cable into it, nobody does this. This is only on fixed wireless. If you want to say something about that for fixed wireless, I think you could maybe get away with it, but I've never seen it on anything other than fixed wireless. I think if you want to say something in 7084, I think we could say should do this, and you could should this or may this, but I would not recommend this out of the box.
Okay. I think I don't remember the exact wording right now in the document or even in 690, but I think the point about the persistence, there was a description about pros and cons of each option. And basically, the conclusion was probably it's better to do persistent, but up to you.
Yeah, I think we should just stick with that.
Yeah.
Like, yeah, you should do persistent. It's great, but there are other reasons not to.
Yeah.
Janrinkova, sorry, it's been a while since I've been dealing with anything which resembles broadband networks. I'm just a bit confused about recommendations. So when I read the draft, from benefits, 127 or even link local looks much, much better from every single perspective, except, as your draft say, it might not be supported, right, by some equipment. No, like, okay, yeah, 127, yeah. So so like I am surprised why you're recommending something which does not have a clear benefit, except some devices might not be supporting this. If I were operating a network and I have recommendations, I would actually want my equipment to support this, and then I can use it. If my devices do not support something which I find useful, I will talk to vendor and ask them to support this. So I'm not sure a recommendation recommended here for /64 is the right thing. If the only reason for that recommended is that some devices might not do anything differently.
But right? I think I missed the first part of your comment. You say that the /64 is not supported?
No. Maybe I misread your document, but you discussing options and you say link local has some benefit. 127 actually has a lot of benefits. /64, well, the only benefits seem to be that everything supports this, right? So I'm not sure we should be recommending something only because everything every single device supports this, maybe we need to push forward introducing support for
Okay.
1/27
Okay.
instead, right? So that's what I'm a
Yeah,
bit confused, right?
we'll need to fix the wording yet to see. Yeah.
Small comment to the prefix assignment. The persistent assignment is a privacy problem for many users, at least perceived. And I think persistent, as long as you renew, probably new prefix when you release and get a new lease would make much more sense for this case.
Well, yeah, that's a very key debate, but I really think that the consideration on privacy, at the end, you are not disclosing the address of a specific host or individual person. You are disclosing the /48, but that's not a privacy issue. I mean, it's so big, the space.
If I know the carrier is always handing out a /48 or /56, I at least have a very small privacy set called a household. And if this is a single person household, I have a single person.
But there are many other ways to fingerprint a specific user regardless of having or not the same IP address. So this is not increasing the lack of privacy in that sense.
I think the only thing that rotation gives you is it like changes the time frame of an attack, right? If you can attack someone, if it takes you more than 24 hours to mount an attack, then it doesn't work. I don't think it's very strong. But what I wanted to say though, for number 3, right? So I don't remember a lot of this either, because it was a long time since we did this, but I remember that in Broadband Forum, there was a variety of different deployment models, and some of them sort of like kind of relied on like local addresses, or rather unnumbered, like they were unnumbered. And I wonder, like, if we say this must be 127, it might just like break that type of deployment. So if we want to say must, we should, or 64, even worse, I think we really need to figure out, okay, like, is there any deployment, any sort of like FTTH deployment or like OLT stuff that like doesn't work with us? Because I suspect we'll find that there's stuff that doesn't work with a /64 and that requires unnumbered, because I remember that they had these 2 separate models, and I think it was done for a reason.
Okay.
Yeah. Hello, Yodi. Tom Hill from BT. 2 points. One, I think this notion that the prefix assigned to the end site must be persistent, it becomes quite problematic contractually. I'm not suggesting necessarily that we should transplant RFC language into our end user contracts, but if you do advertise, or at the very least, if the protocol advertises that once you're giving an IPv6 prefix, as long as you pay your contract, you get to keep it, that actually becomes quite cumbersome from a organizational, operational idea. How do we do any renumbering if we want to increase someone's prefix size, for example?
I think, if I understanding you correctly, you mean that the customer can say, I want to bring the prefix with me to another place, or?
The other way around. I, as the operator, would like to say, your IPv6 prefix is changing.
Okay.
Not very often, no. But, there are situations where if we are giving out /56s to someone, to all of our customers today, we might want to increase that to a 52. How do we then say, you can't have that any longer, you're going to have this prefix instead? If we have to do something for regionalization to make sure that we can aggregate to a different peering LAN, for example, we might actually have to move around some of the pools and reassign the IPv6 prefix. Now, there's a difference here between must and should.
Okay.
And that's very much something where I think there are enough pain points around saying must that it will be particularly problematic for us. The second point was very much what Lorenzo said about unnumbered interfaces. Not every broadband link is Ethernet. necessarily. So we still use PPP. And so, yeah, that could be a bit cumbersome for us. I also don't necessarily agree. I don't think I agree with the idea that you take the first /64 from the assigned prefix to number on the WAN interface. I have a feeling that that becomes quite an issue, because that's an address that's negotiated from the BNG, for want of a better phrase. That's not necessarily your customer's domain. So using a prefix from that set probably isn't the right thing to do.
Okay.
Exactly, right? And that's our link, that's not their link.
Yeah, thanks.
Thanks.
So Nick Braulio, ESNet. I'll be brief. I'm going to agree with, I think, both of them in that, all of the PON networks that I've worked with, they're either unnumbered or they do a slack assignment for the CPE. So, basically forcing that, making that a must, I think it will create problems in a lot of broadband networks. The other thing I would suggest is for number 3 to take a look at, what, if you decide that there needs to be something, take a look at what the problem that the 127 was meant to solve and see if those are actually still problems.
Yeah, I think I have some text in the document describing that, yeah.
Okay.
Ron Bonica, HPE, also harping on number 3. It seems like there are 3 candidates: link local only /127 GUA. Link local only sounds good, except some folks might think that it's unmanageable. Well, given the new extensions to ICMP, it actually is quite manageable. There's probe to look at unnumbered interfaces. There's RFC, I think 5837 or 5387, one of those that does that. So that may be a good candidate. 127, I think, is the second best candidate, and GUA the least good candidate. So you might want to put some discussion in there, give it an order of preference. My order of preference would be link local only 127 GUA, and say, well, you might not be able to do the first because you don't have what you need to do it. In that case, fall back on the next best one.
Well, probably the idea, because it's a long document, is to send to the list specific questions on each point instead of the full document, to try to start fixing each part of the document.
So I think I'm the next one in the queue. So Eric Vink, I would also comment on number 3 because the link local only, this is one of my IRC, so please do it. But more generically, I don't think it's up to the V6OPS to have a BCP selling mass. Informational and recommendation on consideration would be a much better fit. You may consider this before going to your adoption call.
Okay. So you think instead of BCP, it must be informational?
Informational and use recommended rather than must. I mean, nobody will come to your ISP and check, right?
Okay.
Richard Patterson, just keeping the topic going. In the document, it says, GUA is the most common method of doing this. I'm not sure I agree that that's true. The link local, again, just to reiterate the recommendation before, I think that's my preference, link local or unnumbered for the WAN interface. There have historically been reasons why many people who are using, for example, a Nokia BNG will do this. If you're single stack v4, that's 1 host. If you're dual stack, that's 2. And if you number the WAN, that's 3rd. So you're, thirding your scale on your BNG if you would number in the WAN. I think that scale issue has been solved now, but it's been like that for a long time. So, and yeah, the management thing, you don't need to number the WAN. You can just have a loop back from the prefix PD, stuff like that.
Yeah. By the way, I forgot to mention at the beginning that the recommendations that we have in 690 are based on surveys that have been done to ISPs worldwide. So it's not just a decision of that document. It was also what is more common globally. Okay? Done? Thank you.
Thank you.
Chen Hao.
Hi. Hello.
Yes, we
this
can
is
hear
Chen.
you.
Okay, thank you. This is Chen Hao from China Telecom. On behalf of all authors to present this draft, the title is Considerations of Gradual IPv6 Only Deployment in 5G Mobile Networks. Next slide. Quick recaps. This document describes the approach of gradually deploying 464 X-late-based IPv6 only. Actually, is we deployed the NAT64 and DNS64 in our 5G networks, especially on user plane. It also discussed the challenges and the potential solutions. Here, such as the roaming UE's upper layer DNS64 configuration challenges and some potential solutions. To address these challenges, we propose using RA to deliver prefix 64 and DNS64 server addresses. Next slide. To understand this, we have a picture here. When we deploying the IPv6 only in the network, there are two environments coexisting. Which the origin user is are dual stack users. They should we should make sure they get the DNS or normal DNS server address for them, and and for IPv6 only environment, and the IPv6 only users should get the DNS64 server addresses. Next slide. So what has been updated in version 01? We discussed the method for advertising prefix 64 and DNS64 configuration to hosts by combining prefix 64 I option and DNS64 I option. Prefix 64 option is already defined in RFC 8781, but the DNS64 option is not defined, and I have a draft to talk about this. We also discussed some the host behavior, route behaviors, and backward compatibility and coexistence. If the host not support the DNS64 option, just ignore. Next slide. What is the next? We think operators are interested in this topic, especially the mobile operators, because it is necessary for gradual IPv6 only deployment. So we propose more comments and contribution from the work group, and we hope this draft can be adopted as a work group draft. I think this is very suitable for the milestone for IPv6 deployment in the access network. So I'm done.
Lorenzo.
Yeah, Lorenzo Colli. So I think operators have already done this. Like, so for example, I know for sure that NTT Docomo has gradually rolled out IPv6 only. They went from dual stack to IPv6 only gradually over their network. So it might be worth sort of asking them how they did it. If you go back one slide, maybe, why do we need another DNS option?
Because
yeah, go ahead.
Okay. I know some operators like T-Mobile, they already deployed the IPv6 only technology in their mobile network, but I can't find the document about to talk about how to deploy them. So I read this draft, and there is our RFC about the in RFC 8781. It talks about the DNS option, but it don't. We can't get. We don't know through this option to know if this DNS system supports the DNS64 function. I also
DNS64 is a network function. It's not a host function. If you give it sort of any host that can do dual stack, if you give it a DNS64, it will work. Like the host doesn't need to know if the DNS does translation or not, or synthesis. It has no need to know that.
There is a use case. We a mobile network user and the backbone user or wireless user have used the common use one DNS system. We want with our mobile network users to use IPv6 only services, but we don't want our wireless users to use that. So we think we should make sure that IPv6 only user to get the DNS 64 use server addresses. If our dual stack users to use this DNS normal DNS system server addresses, they will have impact on our NET64 equipment in performance, affect the performance of the NET64. We can't we just can't to let all users to use our NET64 equipment.
I guess my point is that you can use the RDNSS option to do that, right? You can, if you want to gradually roll it out, you can just gradually roll out the percentage, that you gradually increase the percentage of users that uses Press64 and RDNSS, right? Because the other thing is like, if a host gets both the DNS64 option and the RDNSS option, what's it supposed to do, right? So anyway, I guess maybe there's other people in the queue.
So I think as you guys, this is Nick Brawley with ESNet. I think as you were discussing that, what I'm guessing that you're wanting to do, and it isn't entirely clear. If you go back one more slide, I think, and correct me if I'm wrong, you want the users of IPv6 only and dual stack to coexist on the same network. That's why you don't want to use RDNSS to disseminate the DNS64. You want something that is unique to signal that. Is that, am I understanding that right?
Yeah, you are right. Yeah.
Okay. I mean, to me, that feels like, you know, a network architecture choice that, you know, rather than create a new APN or whatever to migrate your IPv6 only customers onto, you want them all to be on the same network so that you don't have to touch every piece of CPE or UE. Yeah, like I'm struggling to understand how this really solves that, other than, I mean, because you still have to touch every UE to have it understand this new option. And perhaps I just don't understand, so I'm not, you know, asserting anything, but I'll jump out of the queue and let other people talk.
I have done several deployments in mobile networks, and you can control that by other means. Basically, depending on the PDP context that you allocate to customers. For example, you allocate to some customers only IPv4, some others dual stack, and some others IPv6 only. So I don't really think there is a need for something else.
Right. Okay. So, Chen Hao, we suggest that you maybe talk to Jordi and other people offline to collect more information.
Okay.
And
Thank you.
we move on now. Jing.
Good afternoon, everyone. I'm Jing Zhao from China Unicom. On behalf of my team to introduce our draft IPv6 network deployment, monitoring, and analysis. First, I want to introduce the updates before this meeting. The latest version of our draft is 03. In Section 3, we proposed an IPv6 end-to-end monitoring and analysis system architecture. And in Section 4, we added scenario-based capability examples. And in Section 6, we added implementation considerations. Next, I will introduce the background of our draft. In the process of adverting IPv6 deployment, there might leaking some informations that when we want to try to find the reason why our IPv6 deployment is poorly implemented. So we summarize these into 5 main problems. The first is fragmented monitoring coverage. Monitoring points are mostly focused on backbone networks, and they don't have detailed visibility into user terminals, access networks, or application endpoints. And the second is single dimension evolution. Assessments might depend on basic metrics like IPv6 traffic rate with no full view of transmission quality, network elements readiness, or active connection states. And the third is lack of cross-domain correlation. Data soils exist between different network domains, preventing end-to-end path analysis and fault correlation. And the fourth is insufficient in-depth analysis, incomplete IPv6 transformation in private applications, and content delivery chains is still hard to detect because we lack deep monitoring for these cases. And the fifth is limited dynamic prediction. Current models can't easily measure how extra factors affect IPv6 evolution, which hold back proactive planning, like policy changes, user behavior, and market dynamics. And to solve these problems, we submit an IPv6 end-to-end monitoring and analysis architecture. It including 3 layers. The first is data collection layer. It establishes unified interface standards to integrate mailed source data from home broadband network, mobile network, IP bearer network, and application side. For data collection, it can access the existing network management systems of various professional networks. And the second is intelligent analysis layer. One function is dynamic traffic attribution. Low IPv6 deployment rate regions are identified, and we develop a correlation analysis plan to identify which specific subsystems or two the problems comes from. The other function is user-level topology reconstruction. Maps survive chains, rebuild end-to-end topologies, and support segmented latency pocket loss diagnosis. The third is visualization layer, based on the index practitioner and the decision support. And next, I will introduce the key performance indicators. Most of current systems are local index analyses. In order to more comprehensive show the IPv6 deployment status and analyze the bottlenecks and the block points of IPv6 deployment, we have newly defined a complete set of key performance indicators. There are three kinds of indicators. The first is readiness indicators, including network element readiness, application readiness, infrastructure readiness, network readiness, and cloud readiness. And the second is operational metrics, including IPv6 traffic situation and active IPv6 connection. And the third is quality metrics, including DNS resolution performance, end-to-end latency, and packet loss ratio. Based on the architecture, we develop a system. So I want to show some examples of our system's scenario-based capabilities. The first is IPv6 monitoring and analysis on the user side. The IPv6 port rate in user access traffic of top applications, comparison of IPv6 traffic between mobile users and home users, and others. And the second is IPv6 port and application access quality monitoring for websites and applications, monitoring the IPv6 port status and the quality of the secondary and the tertiary links of websites of applications, and so on. And the third is demonstrate and score the IPv6 deployment status of a region based on the indicator systems. So next, I want to introduce a use case of our system. User network quality issue localization. User A experience lag during home cloud gaming and need root cause technical investigation. Typically, the issue would be expected to occur at N2. However, after conducting a thorough inspection, it turned out that N2 is functioning properly. To address the challenge, the system reconstructed the complete end-to-end flow from the user's terminal to the cloud gaming application, analyzed performance metrics across three network segments, N1, N2, and N3. After analyzing, the system identified abnormal N1 segment latency as the direct cause of the lag. Expert analysis show poor home IPv6 network quality comes from three issues: bad route platform, single interface, and inadequate device maintenance. Next step and discussion. Our objective is to, along with BCP, what will the focus of our subsequent improvement. The more use cases that the system can support and the demonstration of our system at the next meeting, hackathon. If you are interested in the draft or have suggestions on how we can enhance our draft, please reach out to us. Thank you.
Eric Vink. So thank you for the work and the presentation. I assume it's within one single AS, one single operator network, right?
No.
And which is the source of the information? May I assume it's IPv6?
Yeah.
Okay. And you go to the BET gateway placement. So are you going, do you have some information from the home user as well?
Our system now is deployed in our own operate networks as the user that use our network.
Okay, thank you.
Thank you.
Eric Nygren, thank you again for presenting here and for the work. Two quick comments, one of which there's a discussion going on with the Happy Eyeballs working group and on the list here about measuring for brokenness of IPv6. It might be worth taking a look at that and seeing if there are ways to kind of get involved in that, because I think that might benefit from this. On the adoption front, one thing I've found is a way to look at things is not just to look at IPv6, but to start looking at the residual IPv4, because in a lot of networks now, what is actually interesting isn't the IPv6 adoption, because that's oftentimes huge. It's really the residual IPv4. That residual IPv4 is the things that you want to be focusing on to look at how do you start reducing those top residual IPv4 contributors to offload CGNATs and the like.
Thank you. Comment.
Xipeng, I noticed that in one of your slides, you mentioned that, score the IP deployment status of a region. I think that it's not the IETF's responsibility to do this. So you can propose some kind of like monitoring methodology, but please don't write this into the draft. Well, if no further question, then we'll move on to our last presentation.
Hello, Megan. So it started as pure theoretical cleanup stuff, but based on some hallway discussion, I actually think it's not just, it's more than that. So, problem statement. 6052 talks about how translators use IP addresses, and it has very interesting section 3.1, which says that translator must not use well-known prefix to represent non-global V4 addresses. And more than that, translators must not translate such packets and must drop them. Interesting. So why I think it is a problem? Because typical, let's say, enterprise network, which do in V6 mostly, right? I'm lazy. I don't want to run additional DNS6 for servers. I am using public DNS6 for server, which obviously uses well-known prefix, right? If I talk to internet destination, it's all good, but now I want to do ping go SSH 10.0.0.10, and now it supposedly should not work, right? Because 6052 says you must not, right? So I'm trying to understand, like, can we do something about that? Okay, yeah. So IPv6 only node, which is using public DNS 6.4, will try to use well-known prefix to use RFC19 addresses, and it will fail. When 6052 was written, I guess the only way to do this was DNS 6.4, and in DNS 6.4, if you control the server, it's easy to implement. You have just a different view, and you say, okay, for global v4 addresses, you use one prefix for synthesis, and for private address space, you can do something else, and you can do it in your network. Very easy. Now, we less and less rely on DNS 6.4 over time, right? We prefer hosts to do local synthesis, and even for local synthesis, for NAT6 for prefix discovery, it's much better to get it in array. And applications or hosts which could not get it in array will get it using resolving IPv4 only ARPA as described in 7050. So that starts becoming a problem because it's really hard to deal with multiple NAT6 for prefixes if you don't use DNS 6.4 and instead using prefix discovery for local synthesis, right? Obviously, one solution might be you can use network-specific prefix, or RFC 8215 prefix, which is actually network-specific because it's not well-known, so public DNS 6.4 are not going to use it. It means that any network which want to do this would need to run their own local DNS 6.4 server, which actually effort, money, operational cost, complexity, and all this stuff might not be really desirable. So let's say I still want to use public DNS 6.4 and I want to try to use network-specific prefix on top of this, right? What if I use, let's say, Google Public DNS 6.4, but I will start advertising array pref 6.4 with different prefixes? This is going to be operational nightmare because hosts are supposed to use all prefixes they discover to synthesize for a given IPv4 address. So for the same external destination, I might see packets using different prefixes, both well-known and network-specific, and I don't want to troubleshoot this, and I don't want my ACLs to be twice longer because now I need to cover like 2 prefixes. So it does not look like using network-specific prefix is a attractive idea. Come on. By the way, most interestingly, I am not aware of any single CLAT implementation which follows that rule. I cannot prove this, but I am aware of NAT 6.4 implementations which also ignore that statement. I cannot say all of them. I cannot prove that, but definitely some. So basically, operational reality does not reflect this must not, which actually means that if you, for example, decided, oh, let's enforce this must not, we're going to break things which are working already. And we definitely don't want to do this, right? So I was trying to find out why this must not was there in the first place. So that it looks like when 6052 was published, that text, I'm kind of letting my imagination runs wild based on like some digging I did. I don't know for sure, but that text was about DNS 6.4. It was about when you run DNS 6.4, right, and you use DNS 6.4 together with NAT 6.4. DNS 6.4 should not probably, I'm not even sure it must, but it's not, does not sound like a great idea for public DNS 6.4 to return synthesized addresses for private address space. But on the other hand, if you ask DNS, public DNS, and there is a private IPv4 address there, you will get a SA record, right? But I'm not sure it's a big deal anyway, but. So this was about DNS 6.4, not about translators actually, right? And now, in like 15 years later, we're mostly dealing with local synthesis and translators. So this must not is actually much less like useful and critical. So, okay, so to sum it up, we have something which to me looks like a policy decision. It's in my network, I might want to decide, I want to decide, do I want my translator to synthesize for private address space or not? I even might want my corporate DNS 6.4 actually use well-known prefix for my corporate private address space. It's a policy decision. It's a configuration decision. I would like, if there is a reason to have this must not, we were not able to find out what it is. So we have a must not, which creates operational complexity right here, right now, does not seem to solve any real problem. Or for me, must not means if you violate this, things gonna break badly. I do not see what exactly gonna break if you violate it. So it looks like we have something written 15 years ago, which does not seem to really be applicable right now, especially for non-DNS 6.4 use cases. Nothing breaks if you violate this. And by the way, it's already ignored by many implementation. And there is one more thing here. I know that a lot of implementers could not really ship a product if it violates RFC. So I suspect that might be implementations out there which are not ready because there is this must not. So I think we might make their life much easier if we remove this must not as soon as possible. So proposed course of action. Text about must not be used. This is actually slightly different from the draft because the draft was written in a bit of a hurry. I suggest that we say that non-prefix may be used. Maybe we can say DNS 6.4 probably must not do it by default unless configured otherwise. I don't have strong opinion about this part. Translator, instead of must not translate it must drop, I think we should say should translate and must not drop unless configured otherwise, right? Because it's a policy. I think we need to make those packets legitimate and let people use them if they want to. If they don't want them, they will filter them out. So, and this is actually my last slide. I would like to ask for adoption. Oh, 7 people in the queue.
Yeah.
How exciting. Oh, mad.
So, yeah, so maybe look at that from Orange. I won't be, I would say, commenting what you want to achieve here, but I would just provide the context why we had that in the original RFC as one of the authors there. Actually, at the time when we write, I would say the RFC 6052, we had the discussion that if we use the private IPv4 addresses, this will lead to ambiguous translation. That means because we will have, there may be multiple overlapping private IPv4 addresses. So there is no guarantee that there is unicity of the destination. So for example, if you are deploying mobile networks, there are overlapping IPv4 addresses deployed there. So you are not sure that the connection will be terminated on the same site. So this is basically avoid ambiguous translation at the NAT64. So we had a lot of discussion there. So, and then by design, we said, let's close this because at the time, yes, you are right. The assumptions and the way we'll deploy it may be different than what we have today. Maybe we may be relaxing this based on the experience we have. I don't have any option on this, but that's why we have it. It's not a random decision. It is something that was there. The other one is that this working group discuss this again, this point, and the conclusion was to assign this new prefix that you mentioned there about the RFC 8215. It has what it has about, I would say, pro and cons. It's there. Now it's really legitimate that we want to open. If we want to open this, the only, I would say, comment I would make here is that we just need to be careful about opening it for a specific deployment in mind. We have to take this into account in how we'll be relaxing if we decide to relax I would say the statement.
Cool.
Yeah, Lorenzo, I think we do have a sort of a backwards compatibility sort of concern here, right? Like we can't, if someone was relying on this for security purposes, for example, we sort of need to at least say, well, this is sort of like, you don't want like the default to change in a new OS update and suddenly a network becomes insecure or something. But I wanted to say for the point that Med brought up, yes, we have other NAT64 prefixes, but they are network specific because you have to configure them. So they're not well known. They are network specific. Yes, there are many of them, but you have to choose them. No? No, like
it's network specific because public DNS 6.4 do not use them. So there is no difference from me to deploy on this between my network specific and this one, right? So in that regard, it's the same, right? So
there's a bunch of stuff on the internet that will return like, 64FF9B right now. And it can do that because there's only one of them. As soon as you have more than one, then you have to tell it which one to return. Anyway.
Eric Veng, Cisco, and I say Cisco on purpose because indeed there are some vendors, they are implementing this, in my opinion, kind of stupid behavior because they must respect this RFC. So, and I guess I am not the only vendor doing this. So you are pretty right on this point.
So, Nick Braulio, ESNet. I want to strengthen something that Jen said, and that I actually wrote a tool, or created a tool that will test for these things, or to test a bunch of different compliances. And one of them is Section 3.1. Literally nothing that I tested supported that. And I can say with absolute certainty, without being overly specific, that there are at least one major implementation that is held up on non-compliance with 3.1. So, I think that those data points need to be very heavily weighed with the fact that this has seemingly never worked. And so it is the de facto, what's out there.
Yeah. Warren Kamari, Google, and full disclosure, co-author. I mean, it really seems like what we should be documenting is what's actually in the real world. Like if everybody knows that this is a dangerous thing, we should make that clear. To Lorenzo's point, if people are relying on this for security, they've got bigger issues. Yes, we should note it, but like it's really not keeping them secure. What I originally stood up for is for the DNS 6.4 stuff, it's perfectly reasonable to have 1918 space in your v4 space, and a lot of enterprises do. And then they run into this weird issue. Also, a lot of bring your own device things sort of use public 6.4 DNS. So like yeah, we should just fix this.
Jordi Palet. I was in the list, I was not supporting this because I was missing one key point, and it's the usage of external DNS64. It's true that in all the deployments I have done, I use internal DNS64, so then I don't have this problem. Now I am changing my mind. I already discussed this before with Jen, and I think we should relax it clearly. And also, I think the point that you mentioned here about the DNS64 must not use the well-known prefix, that's easy to do because what I was mentioning in the list, you can use different DNS64 by means of views or split horizon or whatever you want to call in bind, for example.
So basically, yeah, I think it would be nice to document what bad things gonna happen if I configure my corporate DNS64 server to use well-known prefix, because I do not see what's exactly gonna happen, right? It's just a prefix inside my network, right? So it's a policy. If I want to I can have different view, I can have the same prefix. I do not see big issues there, but yeah, we can add more text clearly in, I don't know, security consideration somewhere else.
Yeah.
Ron Bonica, HPE. Like everyone else, I agree with the point of this. But your very last slide under the new text, I know what you mean, but I don't think that's what the words on the slides actually say.
I can't even see.
That's okay. I remember what it says. They should translate and must not drop. Well, that also means they might not translate because it's only a should. And if they don't, they can't drop it.
Well, like, okay, so the reason for should here, because I did not want to make those certain vendors non-compliant as soon as we do this, right?
Yeah.
So, like, yeah, we like, again, this is a proposed text, right? Yeah. It's a 00, which was submitted like 2 days ago. Obviously, we can polish the text to make it better. Yeah, I
think should translate period does the trick.
No, I want no, because we have must drop previously. I want to make explicit that they must not drop it now, right? I think this is important for if there are any implementations which are dropping now, not because of policy,
even
but
if
because
they
just
translate.
It's illegal. Okay, fine. Yeah, I see.
Thanks, Jen. Suresh Krishnan, I think like I had a slightly different concern. I think what Lorenzo said, like I kind of buy into that. But the different issue is like you're taking something that's compliant today and make it non-compliant. So I would suggest like make both of these shoulds. I'll send you text for it, but the should not drop means that somebody needs to have a reason to drop when they follow this thing, and the people who are dropping already stay compliant, because I think that's the part I'm worried about. So you did the right change for the must not to may, because they'll still say compliant, but just do all the shoulds. I'll send text for you.
Yeah, makes sense.
But I
Yeah.
do support it. Yeah, thanks.
Thank you.
Tommy Jensen, based on this archaeology you just did to put together all of this analysis, would you say that there's any benefit to a vendor in a world where this exists and they can access all the same endpoints using the well-known prefix as something they allocated their own? Is there any reason anyone should deploy a network-specific prefix from their own space?
I know that people were using network-specific prefix when they run public NAT64 services, right?
Okay.
We tried to convince T-Mobile to use the pref64 thing and like option in the array, and they said no. We use 7050 because we want to assign different like NAT64 prefixes to different like users for load balancing purposes. So people do use it for that.
Well,
I think Ted's got a question, remote.
Yeah, so actually comment about the idea of making these shoulds instead of musts. An implementation that complies with 6052 now will not stop complying with 6052 if you publish this update. So there's actually no reason to make that change. That implementation is simply compliant with the previous version of the RFC. And so I think you should say what you mean in the new version. I would really strongly, I just, being mushy about these kinds of normative requirements, I think is a bad idea.
Okay, thank you.
All right.
Done? No one? Some people in the queue, I just couldn't see the queue.
Yeah, they're just not, they haven't removed themselves.
Okay, thank you.
All right. That's time. That concludes this IETF's V6 Ops meeting. If there's any other questions or comments or discussions, let's take them to the list, and I look forward to some lively talk.
Thanks, y'all.
Thanks, Ted. Oh, goodness. What's that? How did I miss?